These cloud providers, if at the end a pharmaceutical company decides to go with Azure, or a pharmaceutical company decides to go with IBM or whatever provider they decide, for example, I know that Roche Genentech, they are working with two cloud providers. They are working with Google, they are working with Amazon. I know that Novartis is working with two cloud providers, with Amazon and Azure. I know that the European Medicine Agency, they are working with Azure, while the FDA is working with Amazon. So at the end, we are creating again another kind of data silos if we are not able to connect between them. So what would be the standardization of that? Well, there are many standards like REST API calls, like JSON storage, like, for example, in order to create tables for really indexing storage. We are talking about Elasticsearch or Lucene queries. These kind of technologies, Lucene, JSON, Parquet is a format that is already standardized, is compliant with the Alcoa Plus. These kind of technologies are nowadays being tested in order to be transformed like standards. And all the companies, all the cloud providers nowadays, they are accepting all of them because they are recognizing this limitation if they move forward without interact with the rest of the cloud computers. So when Amazon services, they are offering a new service based on REST API calls, based on virtual private cloud, based on this kind of components, is because they are envisioning that they are going to need to connect with other cloud providers. So in the near future, and it seems that it's a standard, all those cloud providers should keep a layer, an external layer that could allow to integrate them in some ways. API REST call, this is something. MQTT for IoT, this is another standard. OPC UA in order to connect industrial systems with the cloud. These standards are already accepted by the community, but not from using a scientific approach. It's because it's a trial and error mechanism. So there is nothing still already established, standardized, but companies that they are doing that in real life, they are proving, they are testing, and they are accepting some technologies that they are more standard than other ones. This is a little bit of theory that I need to describe. Well, this is how cloud systems work. And I think that you need to know these definitions. So from a traditional perspective, from a traditional IT operation systems, when you have the servers on site, all of that must be managed by your IT department. So you have to work with applications, you have to work, or you have to manage data, you have to work with middleware, virtualization, servers, and so on. So everything must be maintained by your IT department in your company. If you move from a classical architecture towards a new architecture based on cloud, we have three different options. One is infrastructure as a service. So you pay for the infrastructure that you use. In this case, we're talking about virtualization, servers, storage, networking. This layer is coming from the vendors. Nowadays, I would like to add a new one because I don't know, when you think about power computing in the cloud, usually you work or you think on virtual computers. Please try to evolve this thought and change this paradigm by lambdas. Lambdas or microservices is the future in cloud computing. A lambda is a function, is a software, let me say, that is created when it's called, when it's needed, and is destroyed when it has finished their functionality. Okay, that would be also inside the infrastructure as a service umbrella. The next iteration is platform as a service. So you have a platform could be, for example, Microsoft Outlook, Google Gmail. That could be a platform that you are using for something, and there are more responsibilities in the vendor hands. And finally, you have software as a service. In this software as a service, you are paying per use, and you have your own applications, you have standard applications, you have software, and you have the rest. So on this layer, the customer, let me say, in this case, the biopharmaceutical industry, the hospital, is not taking care about anything related to the applications that they are running. Everything is delegated in a software as a service provider, and the company is fully dedicated to those objects, to those topics that they are experts. Biotech, drug manufacturing, patient health care, medical attention, and so on. So this is the new paradigm that is evolving, and this is how to move from the traditional perspective, the traditional architecture, where companies, they were taking care about everything, till the companies are paying per use and they are not taking care about these kind of things. But let me share one thing with you. In terms of life science, the validation of these kind of services, when they are involved in critical processes, they are required to be in a specific way. It's not easy, but there are always pros and cons. If you want to read something about that, I wrote an article that was published in the ISPE in pharmaceutical engineering in 2008, describing that in the pharmaceutical industry. This article was really good because it was nominated as the 6th most read article of the year. So a lot of pharma guys were interested in this topic. So that means a lot. So just let me know if you need or you would like to read the article. But let me explain you different examples about cloud and IoT architectures, depending on which scenario we are working, okay? Because this is important to mention. When we have this kind of architectures, we have cloud. In the cloud, we are able to manage the storage, the computation, the analytics, the data governance, and so on. In the edge, we have assets, also we have applications in the edge, maybe it could be a software that is running in our computer, whatever. And we have sensors or devices that they are acquiring raw data. This architecture is not valid for everything. So remember, although we have all the mechanisms in place, the strategy, the roadmap requires to have a roadmap also for the components that we need to be realistic in our implementation. For example, imagine that we want, it's a very simple use case. Imagine that we want to implement a low power secondary sensing environment monitoring. Okay, imagine that you want to implement that in your site. For example, to control a wide room, to control a warehouse that must be under cold conditions, these kind of things. Or imagine that you want to control, for example, when you have low power and you have to switch up external electricity generator. In this case, from this architecture, we only need that. So we need this data coming on real time. We need the connectivity with the cloud, and we need to connect with the equipment that we are measuring. And we need to send this data to the cloud. We need to store this data. We need to compute in order to make calculations, and some applications in order to send the alert or the alarm. So not always we need everything for every single problem. So you need in your strategy to define which is the minimum architecture of components that you need to cover the use case. Another case. This is a remote site monitoring and control a municipal well pump or a lift station. Okay. In this case, this is the kind of components that we're going to need if we want to control this lift station. Okay. So it's very different. And finally, another example is more complex. Hospital. What about if I would like to have a system floor automation in hospitals? Well, in this case, we need more components, orchestration, analytics, and so on. But depending on what we are trying to move to the cloud, you're going to need different components. But I think that for you, it's good to have this list of all existing components in order to make a checklist and identify which of them they are needed in each case. Okay, so you can use that as a very good tool in order to create your cloud architecture for a specific intended use. Okay. Okay. Well, more things. This is coming from 2019. This is the FDA roadmap, and I headline that as something is changing in pharma. Well, the FDA is presenting every year, which is the roadmap that they want to to spend all the budget that they have year per year. That was published on August 2019. Could you see which is the topics where they want to put priority in the FDA in a Federal Drug Administration that they have to take care about food and drug products? So they are paying attention in big data systems for regulatory decision making. They are putting attention in the computational modeling. They are putting attention in cybersecurity and digital health. Could you see that? This is so shocked because the FDA that is regulating practically all the world, they are putting attention in these three main things: big data, computational modeling, and cybersecurity. Nowadays, and this is a presentation that the FDA presented some months ago, nowadays, the FDA is using big data in order to schedule automatically the most critical audits that they are doing around the world. And even more, by the COVID-19, they are detecting anomalies using big data and cloud technologies, anomalies, in order to go fast to those labs that they could present some anomaly in the COVID-19 vaccine. Okay, so this is, well, something nice or curious to see how pharma is changing and how pharma is considering that as a reality.